Okay, so think about this. Every single time you pull down to refresh your social media feed, you're actually kicking off this invisible, super high stakes engineering challenge, and it all gets solved in like milliseconds. Today, we're going to crack open the code and see what it really takes to build that timeline you scroll through every single day. So let's kick things off with a question, kind of like a puzzle. For a huge social media platform, what do you think is the bigger technical challenge? Is it letting someone post a new message? Or is it you viewing your timeline, that constantly updating stream of stuff from everyone you follow? Seriously, take a second. Which one is the real beast to handle? Your gut probably tells you it's posting, right? I mean, sending a message out to the world, that feels like the big action. But as we're about to find out, that simple act of just scrolling your feed, that's actually where the real engineering war is fought. And trust me, the numbers are going to tell the whole story. All right, check this out. At its absolute peak, a platform like this is dealing with something like 12,000 new posts every single second. That's a mind-blowing amount of data, for sure. But here's the thing. For modern computer systems, handling 12,000 writes, as they're called, is tough, yeah, but it's doable. It's a solvable problem. But what's happening on the other side of the coin? 300,000. That's how many people are hitting refresh asking to see their timelines. 300,000 reads per second. That is absolutely staggering. It's 25 times more people trying to look at stuff than to post stuff. And that crazy imbalance, that's the core of the whole problem we're digging into. So how on earth do you even start to build a system that can handle that? Okay, so let's walk through the first try. We'll call it Approach 1, the slow read. This is the most obvious, straightforward way you'd think to build it, and it's actually how the platform worked in the beginning. It uses something called a poll method. So the logic here is pretty simple, right? You hit refresh, and the system just goes nuts. It has to find everyone you follow, then it has to go gather up all the recent posts from every single one of those people, and then it has to frantically stitch them all together and sort them by time just to create your timeline. And all that hard work happens in the split second after you ask for it. And, well, you can probably guess what happened next. Trying to do all that heavy lifting 300,000 times every second? Yeah, that just did not work. The system completely buckled. It couldn't keep up with all those requests. It was way too slow, way too expensive, and it forced them to go back to the drawing board and completely rethink the whole thing. And that brings us to approach number 2, the fan out. Now, this is where things get interesting, because this idea basically flips the entire problem on its head. Instead of doing all that work when you read your timeline, what if? What if you did all the work when someone posts something? This is what's called the push method. The idea behind fan out is actually pretty brilliant. I want you to think of your timeline less like something that's built from scratch every time and more like a personal mailbox. So when someone you follow posts a message, the system instantly runs out and puts a copy of that message into the mailbox of every single one of their followers ahead of time. So the whole process changes. Someone posts, the system looks up all their followers, and then it puts that new message into each follower's timeline cache. That's the technical term for the mailbox. So what happens when you go to read your timeline? Well, all the work's already done. The system just has to open your mailbox for you. For you, the person scrolling, it feels instantaneous. And this little table here just lays it all out perfectly. It's all about a trade-off, right? There's no free lunch in engineering. With that first pull approach, posting is super fast, but reading is slow and costly. With this new fan-out approach, posting is now the slow and expensive part, but reading is crazy fast. Now, remember that 25-to-1 ratio of readers to posters? Well, with that in mind, approach 2 seems like a slam dunk, the obvious winner. So, case closed, right? Well, not so fast. This really elegant fan-out solution, it has a hidden and pretty critical flaw. And that flaw only shows up when we stop thinking about the average user and start thinking about the extremes. This is what's known as the celebrity problem. See, on average, any given post gets fanned out to about 75 followers. So if you look at the chart, a few thousand posts per second turns into a few 100,000 individual writes to people's timelines. And the system, it can handle that. That's fine. But there is a very dangerous little word hiding in that sentence: average. Because what happens when a user is not average? What happens when it's a huge celebrity, or a major news outlet, or anyone with a massive global following? Suddenly, this fan-out model that works so beautifully for most people, it completely breaks when it runs into one of these extreme outliers. We're talking about users who have over 30 million followers. Just let that number sink in for a second. 30 million. So under our fan-out system, a single post from just one of those accounts would suddenly trigger over 30 million separate write operations to people's timelines all across the entire system. It's a tsunami of data from a single action. So here's the new, almost impossible challenge. How do you deliver one single message to 30 million individual mailboxes and do it all in under 5 seconds? I mean, trying to do that every time a celebrity posts something, it would just bring the entire system grinding to a halt. So what do? This is where the engineering gets really clever. You don't pick approach 1 or approach 2. You actually use both. You build a hybrid solution that gives you the best of both worlds. Okay, here's how it works. When anyone posts a message, the system does a super quick check. Is this person a celebrity with a ton of followers? If the answer is no, and for almost everyone it's no, it just uses that normal fan-out approach we talked about. Easy. But if the answer is yes, it doesn't fan out at all. Instead, it flags that celebrity's posts to be handled the old way, using that original pull method, but just for them. And this is the beauty of that hybrid approach. For you, the person scrolling, it's totally seamless. You don't notice a thing. When you load your timeline, the system gives you that pre-filled mailbox with posts from all the regular folks you follow. Then, at the very same time, it does a quick pull to grab the latest posts from the handful of celebrities you follow and just mixes them all together. The system doesn't get overloaded, and your timeline still loads in a flash. So you see, the real takeaway here isn't just about how a social media timeline works. It's actually a masterclass in how to design massive systems. You can't just build for the average user, because the average is a myth. To build something great, something that can actually handle the real world, you have to deeply understand the unique shape of the work it has to do. Not just the average, but the crazy peaks, and most importantly, those outliers, the celebrity problems that can bring everything crashing down. And that really leaves us with one last thing to think about. This celebrity problem, where a tiny fraction of users creates a gigantic load, it's not just on social media, it's everywhere. Think about a flash sale on a shopping site, or a massively popular streamer on a gaming platform. It's the same pattern. So the next time you use an app and it just feels magically fast and responsive, ask yourself, what's its hidden celebrity problem? And what kind of clever hybrid solution are they using behind the scenes to make it all work? Thanks so much for joining me for this deep dive.